City, your reporter. Today's breaking news is where is the missing coral in Mimoleaf Aquarium? Christina G, an honorary staff in Mimoleaf Aquarium, was feeding clownfish when he found out the coral reefs down in the pool seem a little less than before. This simple discovery may lead to a huge problem, which is water acidification. Next, let's follow Christina and recover the mask options. Christina, I'll share something about what happened in Mimoleaf Aquarium. So it's a long story. Okay, so that's a long story. One day, when I was feeding my clownfish, I suddenly found out that there's something wrong with my coral reefs. It seems smaller than the very before, and I actually wonder why it happened. And now, let's see where I fed my clownfish. And now here's where I fed the clownfish that day. So here's where I fed the clownfish that day. You see, this tub is what we found our coral reefs missing, and now we already cleaned it up, but at that time, there are clownfish and coral reefs in it. And I just wonder, why are my coral reefs missing? Yeah, this is a problem, yeah. So I got just very fussy, and I went to our team leader, Jack, and asked him what happened. Sir, there's coral missing in our aquarium.
So you mean that our coral is missing?
Yes. What are we gonna do now? Yes, we must find the murderer together. What happened next? Next? I just got the most horrible day of my entire life. After such a long discussion, I just went back home and wanted to find something to drink, and I just opened up my refrigerator and found that an egg. I accidentally dropped it into the Coke. Oh my God. I didn't clean it up at time, so when I opened it up again, it's a tragedy. It's just like this. It's just like this. That's the worst thing I've ever saw in my entire life. So disgusting. So I just checked it quickly on the internet, and I got an equation. Chemical equation. And then I soon came up with, maybe this is the reason why my coral reef is missing. So I gathered up one of my colleagues. And that's it. Oh my gosh, that's hard work. Of course, but it will be easier if we do an experiment to show it. Really, an experiment? Do you have an idea? I was thinking about it. Maybe we can use some corals, or like dead corals. Yeah, there are piles of them. And we can make solutions with different pH. And the more we can use to be acidic, and also the more acidic, we'll put the same coral in it, and we'll observe the change of their mass. And maybe we can determine whether the pH will influence the mass of coral. Yeah, that's a good idea. Well, I think we have to control the volume of each solution. They have to be the same, and they have to be placed in the same place for the same time. Sure. And in the same temperature. Yeah. And also, I think the mass of the coral at the very beginning is hard to control, because we can't really find the corals with the same mass, so maybe it's better for us to see the change of mass. Yeah, we can calculate the proportion. And then, compare them. Yeah, we can draw a graph and show it more clearly. Yeah, let's do it.
So, our experiments will be focused on the topic how does the pH of seawater influence the mass of coral. In our experiments, we will add different chemicals to make different solutions with different pH levels. We will measure the mass of dry dead coral before and after soaking in acid. Moreover, we will control the volume of each solution, the bottles we use, the location, the temperature, and the amount of time to be the same. So, our hypothesis is that if we put dead coral in bottles of different solutions with different pH and wait for 1 week, then the coral that is put in the solution with smallest pH will show the biggest change in mass, because pH refers to hydrogen ion concentration, and when pH gets smaller, the solution is actually more acidic, and therefore the calcium element is consumed by stronger acid. In our experiments, we used 8 dead coral from our helpful classmate, 4 water bottles from Red Maple Leaf store, which cost us 8 RMB, a pH machine from the school lab, a citron from our school lab, a knife from Agnes' home, a free pH puffer from our classmate, a glycerol from school lab, graduated cylinder from school lab, bakers from school lab, scotch tape from our counselor, balance from school lab, markers from school lab, protective equipment, 3 airtight 700 milliliters glass jars from Christina's home, a carbon dioxide adder from Cindy's home, 2 bottles of blue Pepsi from Red Leaf Shop, which cost us 30 RMB, 3 raw eggs from school cafeteria, which cost us 6 RMB, and tissue from our own classroom. So that it cost us 127 RMB in total. During our experiments, we first cut the water bottles with knife into beaker-like containers, clean and disinfect them. 2, we make 4 different solutions with pH of 3 to 4, 5 to 6, 7 to 8, and 8 to 9 by adding citrin and free pH buffer. We use glycerol to perfectly dissolve them. 3, we use graduated cylinder to measure 200 milliliters for each solution and pour them into bottles. 4, we use pH machine to measure the pH of each solution and label them on the bottles. 5, we dry the coral, divide them into 4 groups, and weigh them by group with different mass, because it's hard for us to find dead coral with the same mass. 6, we put different groups of coral into different bottles of solutions, and we use transparent tape to seal the bottles. 7, we keep the bottles in the classroom under table and wait for a week. 8, we take the coral out, clean them with tissue, and dry them in room temperature. And at last, we weigh the coral by group and record the measurements. And here is the result that we get, a graph and a table. We can see from them that the coral soaked in solution with a pH of 3.4 lost the most percentage of mass. So it is evident that more acidic a solution is, the more percentage it will consume the coral and leads to the most percentage of change in mass. The coral soaked in solution with a pH 7.25 and pH 8.01 has slight difference in mass proportion, but the one with a lower pH consumes a bigger proportion of mass compared to another one. Generally speaking, the more acidic the solution is, the more calcium elements it will consume. But our coral soaked in a solution with a pH of 5.9 had the least proportion of change in mass, which is unreasonable. So there must be something wrong that we ignored. It might be because that we didn't clean and dry all the coral carefully before our experiment, or the solution we make has different pH as it shows. So because of our general pattern, just like our data shows that the solution with 3.4, 7.25, 8.01 pH have 12.08%, 9.42%, and 9% percentage of loss in mass. So the lower the pH level is, the more calcium is consumed in relation to the original mass of the coral.
So, Christina, what result did you get from your beautiful experiment? Well, just now you have seen the data and the graphs, and our conclusion is that the more acidic the water is, the more mass will the coral lose. So, did all your corals follow this general pattern? Well, you see, the first, the third, and the fourth group, they all follow this pattern, but there's an exception, that is the second group, and it just doesn't fit our conclusion, and we have discussed and considered about it, and we think that there must be some error we made. Yeah, so there must be some reason that can cause the error. What do you think these reasons are? Yeah, first of all, I have to say that maybe it's my fault that I didn't clean up the container at the very first. Maybe I left some water in it, and that caused the pH to change. And also maybe we just made the solution at the very first, and the pH machine showed a different pH as it really is. So these are all our error source. So what do you think you can do to improve your experiment? Just as I mentioned just now, I will try my best to be more careful about all the cleaning jobs, because I now believe even the tiniest thing will cause a big influence to the whole project, and also we'll try to use maybe more precise machine, and we'll do better at the experiment. So we all know that this little experiment does not only go shopping in the local market instead of buying things on Taobao or on the internet, because the transportation will bring harm to our environment, like the carbon dioxide, and to something else like the package, and it costs the factory to produce more and more wastewaters and pollute the sea. And also the government should let the factory filter their water, and then we can get rid of them and we'll do better in our environment. So, okay, thank you very much, Christopher here. So we're inviting you to step forward and to protect our coral process. That's all for today's City Talk. Thank you so much for coming. Thank you for your story. Christina, good job today. You too. Let's go have supper together. Sure. So, Christina, are you considering doing another experiment in the future? Of course, we are thinking about getting really lively coral from the ocean. That's cool. Also, we'll do a longer time observation, so it's more likely to the real ocean environment. And also, we'll do more precise pH and the solution, and to make it just like the real life. Yeah, I think that's a good idea. I'm looking forward. Okay, thank you. Let's go.